Okay, so these are our word type of problems. First thing you need to do is take a look at it. So we need to find, first off, an appropriate equation or inequality. Then we need to solve it, and then we need to justify the reasonableness of the solution. Okay, so let's come in and take a look at number one. It's a flower garden in the shape of an isosceles triangle. So the first thing I always like to do on these is to draw a picture. Doesn't have to be pretty, just a picture. Remember, in isosceles, these two are equal. Okay. Each leg is twice the base. All right. So we notice that everything is given to us here in terms of the base. So let's call the base x. So now what we need to do, and the perimeter is 256 meters. So we need to write, well, let's come back and take a look at this. So the perimeter is going to be equal to 2 legs. They're both equal. Okay, so I'm going to have leg plus leg, which is 2L, plus x. And that's all going to equal to 256, which is my perimeter. Okay, so now what we need to do is come back in and solve for one of these. And they give us that each leg is. So this translates to L equals 2 meters shorter than. So 2 meters shorter, I'm going to be subtracting 2, twice the base, which is 2x. And then I take this and I substitute it in for my L. So I'm going to have 256 equal to 2 times 2x minus 2 plus x. I'm going to solve for x in all of this. So the first thing I do is clear my grouping symbols, my parentheses. So I'm going to distribute. And then I'm going to combine my x's. I'm going to have 256 equals 5x minus 4. Okay, I'll add 4 to both sides. So 260 equals 5x. Then I divide by 5, which will give me that x will equal to 25 meters. Excuse me, 52 meters. All right, so we need to find the dimensions of the flower garden. We've got x, it's 52. To find L, I just plug this number in for x in here. So L is going to equal to 2 times 52 minus 2, which would be 104 minus 2, which is 102. So each leg is going to be 102. Okay, now to justify these, there are 2 ways you can do this. First off, and probably the best way is to come in and say, okay, here's my x, 52, 102, 102. So for 256 meters, these are reasonable size numbers. If you get a negative for one of these, you've definitely done something wrong. So the numbers are reasonable. The other thing to do then is to come back in and check, which is to put these numbers back in onto perimeter. So I'm going to do this, I would have 2 times 102 plus 52. And when I work that all out, that is 256. So that checks. And if I plug x in for this, this is how we solve this thing. So we know then that 52 and 202s will give us a perimeter we need. And that's another good check, is to plug into one of the equations and check it. Okay, so now let's take a look at number 2. Okay, bring in 100 and do it. Okay, to enclose an area. And we're looking for the length of each side. Okay, so they're roping off an outdoor area adjacent to the sales building. So I'm going to have a sales building up here. Here's my building. Longer side of the roped off area. All right, so let's call this X, being my longer side. Now, we'll call that L to the length of the shortest side. Okay, so I've got a smallest side there, and shortest or smallest side there. So let's call that X. Okay, so let's come back in then, and I'm going to take this up. So we're going to rope this thing off, and we're going to have 3 sides of this. Is roping off adjacent to the building. So the longer side is going to be here. All right. Call this my shorter, and then this will be the 3rd side. Call it T for now. Okay. This is how much rope is available, so that would be a perimeter. 6 inches, so we have 111.5 feet. And that's going to equal to short plus the long plus the 3rd side. Okay? All right, now, what we know then is we need to solve these things, and they give us these equations here. So long is 5 feet shorter than, so it'll be minus 5, 2.5 times the length of the small side, so 2.5 S. Okay, well that's good. The 3rd side, which was T, is 16.5 feet longer, so I'm going to add 16.5 feet, then half the shortest side. And there we've got this. So what we need to do then is come back in and substitute this for L in here, and substitute this for T in here. So I'm going to have 111.5 is going to equal to S plus 2.5 S minus 5 plus 0.5 S plus 16.5. And now we're going to solve for S. Okay, so I'm going to combine all my S's. So S plus 2.5 S's is 3.5 S's, plus another half an S gives me 3 S's. Okay, and then I've got minus 5 plus 16.5. That will give me plus 11.5. 0.5. S, that gives me 3.5. That should be 4S. Okay, so because 1S plus 2.5 S's is 3.5 plus a half is 4. Okay, so now I'm going to subtract 11.5. So I'm going to have 100 equals 4S. Divide by 4. S is going to be 25 feet. Okay, so now I plug that back into here. So that's going to give me 2.5 times 25 minus 5. And that will give me 62.5 feet. And then I do the same thing here. So I'm going to have 1/2 of 25 plus 16.5. And that will give me 29 feet. Okay, so we've got all of that. Now to justify this, first thing I want to take a look is to check all of this. Remember, S is my shortest side. It was 25 feet. My other two are 62.5 and 29 feet. So my shortest side is indeed shortest. My longest is indeed longest. And then the last thing to do then is to plug all of these guys back in. So you want to add 25 plus 62.5 plus 29, and if you add all of those up, it should give you 111.5, which is the perimeter that we checked on. And that's our answer. Okay, let's take a look at number 3. This is basically a physics problem. You look at it. So 2 trains leave Santa Fe. So there's my Santa Fe station and travel in opposite directions. So one's going to go this way, and one's going to go that way. Okay, one of them is going 64 kilometers per hour. It doesn't matter which one. And the other one is going 72 kilometers per hour. Now you should recognize this as velocity, kilometers per hour. We want to know how many hours, so we're looking for time as our unknown. Are they going to be a distance apart? So the first thing we need to do then is calculate our distances. Okay, so let's call this train 1, call this train 2. So the distance for train 1 is going to be its speed, which is 64 kilometers per hour, times the time. The distance for train 2 is going to be 72 kilometers per hour times the time. Okay, now what we notice here then is these guys are going in opposite directions, which means that their distances are adding. In other words, they're getting farther and farther apart. So my total distance is going to be equal to distance for train 1 plus the distance for train 2. Okay, and the total distance we're looking at is 612. I've got 612 is going to equal to D for train 1 plus D for train 2. And then I plug back in. So distance for train 1 is 64t plus distance for train 2 is 72t. And I solve for t. 612 is going to equal to 113, 116. Times 2, that gives me a 6, 136 t. And then I divide by 136. And I find that my t is going to be 4.5 hours. All right. So how are we going to justify this? Well, first off, this seems like a reasonable time, okay? We're obviously not negative. You would sort of wonder if it was going to take them several days. So 4.5 hours is reasonable. And we can come back in and actually plug all of this back in. So the distance for train 1, if we plug it back in, is going to be 64 times 4.5. And then we calculate that one, that's 72 times 4.5. And then when you add them together, they're going to add back up to 612 kilometers. And that's what we were looking for. All right, let's take a look at number 4 then. It's a little more of a math problem. So I need to find the integers which the following is true. Okay, and we're looking for a number. So number, let's call x. So what we need to do here then is come back in and start setting this thing up. And this is basically just a straight translation problem. So 4 less than, that's a minus 4. 4/5 of the number, which is 4/5 times x, decreased by, which means minus, twice the number, which is 2x, is less than or equal to, so less than or equal to 3/5 of, so I'm going to have 3/5 of the sum of the number x plus 4. All right, so now to solve this, we need to come back in and do all of this. Now the first thing I notice is I've got fractions with 5. So I'm going to multiply everything by 5 to clear my fractions. When I do that, 4/5, or 5 times 4 is 20, divided by 5, gives me 4x minus 20 minus 10x. It's going to be less than or equal to, and since this is a product of this, 5 times 3 is 15, divided by 5 is going to give me 3 times x plus 4. So now I've cleared out my fractions. 4x minus 10x is going to give me negative 6x minus 20. It's going to be less than or equal to 3x plus 12. So I'm going to subtract 3x and add 20 to give me negative 9x. It's going to be less than or equal to 32. And then I need to divide by 9x by negative 9, which means I have to switch this. So that's going to mean that x is going to be greater than or equal to 32 ninths. Negative 32 ninths. Okay? And we need to find the integers for which this is true. So negative 32 ninths is going to be negative 3.3 repeating. And we need to find all of the integers which are going to be greater than that. So x is going to be negative 3, negative 2, negative 1, 0, 1, and on. And that's that answer right there. Okay, let's take a look at number 5. That's the next one. Okay, so she wants to purchase a used car. that costs $9,000. She wants to pay off the car loan in 4 years, so there's time. What simple interest rates allow for not spending more than $3,000 on interest? And here, interest is going to equal to our principal, which is this right here, times rate, which is in a decimal, times time. And the rate is what we're looking for. So we start plugging numbers in. Interest is 3,000. She doesn't want to spend more than 3,000. So 3,000 is going to be the upper limit. But she could probably also live if it was equal to it. And that's going to be equal to the principal, which is 9,000, times the rate, which is our unknown, times time, which is 4. So 3,000 greater than or equal to 36,000 R. So we're going to divide by 36,000. Which means that our R then, or excuse me, let's keep writing it the way we got it. So I'm going to have 1/12 going to be greater than or equal to R. Or R is going to have to be less than or equal to, if we plug this in, it works out to be 0.083. Repeat. Or the interest rate must be less than or equal to 8 1/3%. Again, this seems like a reasonable number, okay? And that's how you would justify it. Okay, number 6 is the last one we're going to work on. So she's going to this high school. They follow a six-week schedule, which is what we're doing too. 3 of the 6 weeks, 3 are in the spring. Okay. She knows she has to have an 82 to pass in the spring semester. Okay. So what we know then is she got an 88 for the 4th and a 78 for the 5th. And the average has to be over 82. So if you remember, the average is going to be, so this would be your 4th 6 weeks, plus the 5th 6 weeks, plus the 6th 6 weeks, divided by the number you have, which is 3. And that has to be greater than or equal to an 82. She doesn't want below an 82, but she can live with it being above an 82. All right, so now we start plugging in numbers that we have. So the numbers we've got for the 4th 6 weeks, she had an 88 plus 78 plus, there's our unknown, is the 6 6 weeks, over 3, will be greater than or equal to 82. So the first thing I'm going to do is multiply both sides by 3 to clear that out of the denominator. Instead of dividing, I'm going to do that. So now I'm going to end up with 88 plus 78 plus x is going to be greater than or equal to 246. 88 plus 78 is 166, plus x is going to be greater than or equal to 246. And I subtract 166. So she knows her grade has to be greater than or equal to an 80 on the 6 6 weeks in order to pass biology.